Well, good morning. We're a small coffee group this morning, but that's actually kind of fun. So we can be a little more informal and take questions as we move along. Anyway, this is about the COVID update, what worked, what didn't work, and what the future might hold. I mean, I think the numbers tell us that the Zoom era is coming to an end. And that's no bad thing. I'm very much looking forward to live meetings, as you probably are too. But there are advantages to Zoom because it means that people living in remote areas where it's not convenient to come or be part of this can be. So that's a little unfortunate. So these have been strange times, and let me see if this. There we are. Well, I'm just talking to Debbie about this because this is very intriguing. These are footprints on the south coast of Spain of 35 people, most of them adults. I think there were 7 children involved, and they were walking along in a leisurely way. The children were cavorting about and crisscrossing one another and perhaps even dancing in the sand. And the prints became fossilized. And the prints go back 100,000 years, long before modern humans were in Spain or anywhere in Western Europe, for that matter. So these are the footprints of Neanderthals. And I mean, it's hard to look at these footprints and imagine what was going on and not think that they might have felt many of the same feelings we might feel playing or walking along a beach anywhere, and perhaps even talking. They probably possess language, and many of our similar feelings to us. And we know that they created art, whether it's somebody else. And so anyway, I love these footprints because they're more evocative than I think looking at skulls or reconstructed faces, at least for my imagination. So COVID times, well, these have been really weird times, haven't they? And I just listed a few of these: coyotes strolling streets in San Francisco in broad daylight, jackals wandering a city park in Tel Aviv. I did hear about this from an English friend of mine, but mountain goats taking over a town in Wales. The canals in Venice, believe it or not, were actually cleared. Goslings walked down the middle of Las Vegas Boulevard. But I think one of the lasting impressions I have is just wandering around town to the post office and in the stores, is a kind of general wariness of people, weariness and wariness, and a sense of isolation, a sense of people kind of keeping their distance. And I think that's been really hard. When you think about this whole story began in the latter part of 2021. At least that's when the World Health Organization was told by the Chinese that something was going wrong. And that was in November and December, and then it began. So it's been a strange world ever since. Now, one of the things that I rather liked was the editorial in the New York Times. So on July the 4th, very appropriately, and I'll just read this. I don't like reading stuff, but anyway. This is a good one because it captures the moment, and it captures the moment for Canadians, I think, as well. For all the missteps in its early days, the American coronavirus, translate Canadian, vaccination program is poised to go down as a triumph of public health. 7 months after the first shots were authorized for emergency use, 65%, I think it's 70% in Canada, 66% of adults had at least one shot. So 100 million Americans had at least one shot. That's a very impressive figure. Actually, I think our numbers are more promising in the United States right now because they've run into a wall of resistance about getting vaccinated, unfortunately. And then the next one, it's worth pausing to acknowledge the triumph, and it is. You know, it's not a. We kind of got into this, and it was a disaster, or it's been a disaster in many places in the world, and we're kind of, it's kind of still simmering, as you'll see. It's not over, but anyway, worth pausing to acknowledge the triumph. Last summer, the nation was praying for vaccines that would be at least 50% effective. By the way, I dug up an essay I wrote about that time for the Lake Report with very much that message, that we didn't really know where these vaccines were going. The clinical trials hadn't been completed. We didn't know what to expect. We thought 50 or 60% efficacy would be, we'll take that. And we were stunned because the efficacy turned out to be, at least 80%, and at the better ones, 90% plus. So, and this summer, millions of Americans and Canadians have been inoculated with vaccines that are more effective than many dared to hope for. Absolutely, that's the way to put it. So here's the culprit. So on the left, the image on the right looks like something my mother might have concocted out of wool, but it does show the coronavirus. I mean, the hallmark of the virus are all these studs, spikes, sticking out from it. Probably around 50 to 100 of them, depending on which particular virus we're talking about. But they're sticking out. Those are the points of contact with any cell that the virus is infecting. But the real picture on your left is an electron micrograph, and it shows a cell down below here. But here are all the viruses out here, and you can see all the little black dots are the spikes. And you can see that some of them got inside, are already inside the cell, and in some cases, some of the spikes have broken off or been detached from the virus. So that cell is infected. Now here's a kind of a modeling of the virus, just showing the genome of the virus. Now the genome of this virus is about 30,000 base pairs. To put that in perspective, a single strand of DNA has 3.2 billion bases. So this is a little less than 30,000 bases, but more than enough to cause a lot of mischief. Now, this is the whole genome kind of wrapped around in a circle here. But this is the part of that genome, probably around 15% of it, 15 to 20% of it, which is the part of the genome that the messenger RNA vaccines have targeted, because these are the genes that are provide the blueprint for those spike proteins. It's also the area of the genome of the virus where most of the mutations have taken place since, and they've been marked out. See these little lines here? That's the part of the RNA in the virus that instructs for the spike proteins. And at least in this diagram, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I think it's up to almost 20 mutations. Now most of these mutations, those are the worrisome ones, I might add. Most mutations are benign with no effect, but it's the ones that enhance the transmissibility of the virus or potentially make it more lethal, which are the worrisome ones. So we're going to talk about that because of the Delta variant that's making its way around the world. So, and we're in a new world of physics and chemistry where they're one, and this is a computer construction of what the spike proteins actually look like. Proteins are strings of amino acids. And depending on the order of the amino acid, that shapes the protein. And the protein also has a charge. So some areas are more negative than others, or more positive than others. That has a big influence on how well these spike proteins attach to host cells. So it makes a big difference which mutations, where the mutations are, and the impact of those mutations on the spike protein. So we've just, the artist who put this together, it's kind of put in, well, where these particular mutations have taken place in the spike protein, and it's seemingly all over the place, but it's really the area of the spike protein that's in immediate contact with a receptor on the host cell membrane, and is responsible for, in a way, opening the door, the key on the lock. It opens the cell and allows the virus to enter the cell, carrying its shell and the spike proteins, the debris of which you saw in that electron micrograph just a couple of slides ago. But dumping its RNA there and taking over the cell's machinery for making its proteins, and drives that same machinery to make all of the components of the virus. And so some cells are jam-packed with thousands of completed viruses before the cell ruptures and then spills those viruses, killing the cell and spilling the manufactured viruses out into the circulation. So that's how all of this kind of happens. Now, we would think, after almost 2 years of living with this coronavirus, that we might feel ill will towards viruses, but far from it. About 30% of our genome, of the human genome, and most mammalian genomes, consists of the debris left over from hundreds, even thousands of viruses. And most of that genomic material is junk, or what's considered junk, adding no value, detracting no value, and harmless. But sometimes that genetic material was actually important to acquire. And one example of that is the hemo protein. That's a protein produced by the fetus and the placenta, and that protein was originally viral protein and goes back 100 million years. That's a long, long time. And so this courtship, this relationship that we have with bacteria and viruses is a courtship. Maybe that's the wrong term, but anyway, that relationship has been going on a long, long time. This long, long time, and we're just seeing a tiny little part of that relationship right now in this pandemic. Now, it's interesting that epidemics, maybe not pandemics, but epidemics, have a history with coronaviruses, and one study, for example, found 42 genes in the DNA of living East Asians, and they had similar anti-coronavirus mutations, which probably dated back 20,000 to 25,000 years ago, and were probably acquired over several centuries, suggesting that there may have been several cycles, perhaps like we're going through here, 20 to 25,000 years ago. So this is the latest act in a long running play. So something to think about. Now, the next two, this is the number of cases. The number of cases identified by some test, some blood test or tissue test. This is not the number of cases that are symptomatic. So here's the United States, and the picture would be very similar in Canada. And when I look at Canadian, the incidence of cases in Canada, I just divide by 10 by the American one. It's pretty much the same. The phase relationship, the time relationship, isn't quite the same, because you notice here that here's the first wave and the second wave, and guess why this big wave here? That was fed by the UK variant. That's the mischief that a virus that's 50 to 60% more transmissible can create. We lived through this stuff in 2020, those kind of waves. And then what happened in here? What happened was New Year's in Canada and in the United States, closing cottages, getting together indoors, Christmas, New Year's, shopping, that kind of thing, and governments almost everywhere being reluctant to spoil Christmas and avoiding a lockdown. And that created, and with a virus that was much more transmissible. And it created this huge surge in cases in Canada. And I'm very, speaking on a personal point of view, I mean, this is what caused wreaked havoc in nursing homes, long-term care facilities. I mean, it's really impossible with surges of this magnitude to keep leakers out. It doesn't matter what your vigilance is like. And taking temperatures is almost useless. And asking people to go and get a PCR test once a week, every 2 weeks, that leaves lots of room for leakers to get in. And a lot of those leakers, it wasn't delivered. They didn't know that they had the infection. Many of them had no symptoms. They went to work. They had been celebrated over the holidays, family events, that kinds of things. And bingo, all of a sudden there were no cases, and then there were a lot of cases. And I think most of those long-term care facilities, 80 to 90% of the residents got COVID, and some of them died. Most of the dying in this pandemic has been in long-term care facilities. No surprise, people are congregated together in close quarters and very vulnerable. So that's the United States. That could be Canada right here. Now let's look at the world here. Now, the curves look almost the same, first wave, second wave. This is the world, all of the cases around the world. But look at what's added on here. This is South America now. This is South Asia. This is the Philippines. This is a lot of countries where the pandemic is, there is no vaccine, there's too little vaccine. Healthcare facilities are overwhelmed, very little money. It's a huge place for the virus to mutate and multiply and create new variants. So this is a worldwide problem to solve. It isn't a problem just to solve in Canada. It's not one that's solved by borders. So I think that's very important. And by the way, this was driven by the Delta variant, a lot of it. But there's more than the Delta. The UK variant was still in play, and the one in Brazil. And by the way, those variants have now got children, one that kind of subvariants, as you might expect, second to third generation variants of variants. And when we speak of a variant, we're really talking about several mutations, a particular combination of mutations. That's what we're talking about. Now, I don't know whether we really need this, but just to recap the time course of the illness, there is an incubation period, no symptoms, contact maybe in a pub or wherever it is, or some family event, social event, and several days, 5 or 6 days. And for many people, who are middle-aged and younger, they may develop no symptoms or just a little minor cough, maybe a little fever, but not much else. Some are more obviously ill in that after that 5 or 6 days of the incubation period. Then some develop symptoms, but many do not. Of those who do, and the symptoms kind of take hold, some of them, 30 or 40% of 30 to 40% of them become short of breath. What's that tell you? It means the disease is in the lungs. Now, that's what it's telling. This is a disease that attacks the cell lining of the upper respiratory tract, the lower respiratory tract, cell linings in the heart, cell linings in blood vessels, whether they're veins or arteries, cell linings in the bowel, you name the tissue, some epithelial cell, and that's the target. So people who get short of breath, that's the warning that the virus has moved into the lower part of the respiratory tract. A small number of them develop more troublesome symptoms, and about 5% of them become critically ill. That means hospitalization. That means probably ventilatory support. So, and that's what the lungs look like in somebody with well-established pneumonia. All that white stuff in here is essentially destroyed lung. And the virus gets right into the alveolar sacs, and there are thousands and thousands in the lung where gas exchange takes place. A lot of the capillaries and small venules there clot up, so blood can't get in or can't get out. Those alveoli become filled with inflammatory fluid, so you can't get air in or out. And so they're essentially dead areas, non-functioning areas of the lung. And they're often destroyed areas of the lung, so they don't recover. So that's what the lung looks like. And of course, it attacks other tissues, but in this case, it involved, this person had a massive stroke involving the middle cerebral artery, probably speechless, and lost vision on the other side because there's another ischemic infarct back here. So, and you can see the brain swelling here, the brain's being pushed over to the right here. So, I'm not going to march through all of the organs, but it can be a very devastating disease. Now, the case management in the first few months, remember when it hit the eastern seaboard, particularly New York City, but in our country as well, the equivalent. So many people at risk with comorbid conditions or older age, but whatever, higher risk, ended up severely enough ill to be hospitalized and often in intensive care units. The mortality rate in intensive care units has gone down by about 20%, but not because of any new miracle drug. There aren't new drugs that are responsible for that. The protocols for what to do and when have changed a lot. And that's especially applied to assisted ventilation. And also the realization that dexamethasone can be very, very effective. That's a corticosteroid in very high doses. And because of this tendency to avoid clotting, anticoagulants. But really, it's taken a long time for people to figure out the best way to manage people in this acute care setting. That's changed over a year. Now, what's worked? Well, guess what? Public health measures have worked really well. When's the last time you've had a cold or the flu? So wearing masks and distancing from people and being in small bubbles pays off. Never mind the coronavirus. Well, colds are, of coronaviruses of a different kind. But anyway, so these measures really work. They, remember the phrase, flatten the curve? Well, flattening the curve works, especially combined with lockdown. But if there's one consistent theme through every country, or almost every country that I know about, lockdowns have been reluctantly imposed too late. And how much too late is too late? Even a week makes a difference, or 2 weeks. In this town, this very town here, there was a 2 or 3 week window. And if the lockdown had occurred earlier, many of those people in long-term care facilities who got COVID, and the staff, or I don't know about the staff, but the residents might not have got the disease because the vaccines were just being delivered in February, access to vaccines in long-term care. So, but it was a kind of a week, 1 to 2 weeks too late. My daughter, I mean, in Alaska told me, no, this is fortuitous, but in the capital of Alaska, they were lucky, the long-term care facilities, because they had access, the residents had access to vaccines several weeks before the pandemic hit them. And there were almost no cases of moderate or severe COVID in those long-term care facilities. It's not that the staff were any smarter or more clever or anything else. They were vaccinated, and they were lucky enough to be vaccinated before the wave hit the home. There's a big lesson in that. So what worked? Vaccines? Well, I mean, it's been incredible. Other vaccines have often taken years to develop, some many years. The technology for this has been a high-tech vaccine development program. There has been a high-tech vaccine program here, especially with the messenger RNA, or the RNA vaccines, but also the DNA, the AstraZeneca vaccine. They knew what the genome of the virus was. They knew what it was in December and certainly early January. They had the technical facilities to develop the vaccine, at least in small amounts, enough to run clinical trials. And it was magic. I mean, we maybe take this for granted, but if this had happened 10 or 15 years ago, the cost would have been much higher. It would have been a real disaster. And it's been bad enough the way it's been. Now, have there been hitches? Of course there have been hitches. Whenever you scale up something that you're making small amounts of to making millions of doses, potentially even 1 billion doses, there are problems. And we saw that with the Johnson & Johnson. AstraZeneca had some problems. Pfizer had, they all had some problems somewhere along the line. And then, of course, the whole issue of distribution. Who gets it first? Just getting it in the hands and be able to deliver the jabs has been an extraordinary thing. And Canada has fumbled somewhat. The United States has certainly fumbled. The UK fumbled. Europe has fumbled badly. So everyone's fumbled. There's plenty of blame to go around, but I don't think we should be in the business of assigning blame. This was a very rapidly ramped up program that was amazing, has been amazingly successful. And hitches are to be expected. And we've had them. I've been wrong, personally, at least on 2 issues. One, that delay between the first and second shots, because I thought, now that was really based on the Brits were the first to do that. There wasn't enough vaccine to go around, so a decision was made. It turned out to be the right decision to get at least one shot into as many people as possible, even if you had to delay the second shot for others. And it's turned out it's worked. And it's worked very well. In fact, it might even be better to have the longer interval between the two shots. The hurry up clinical trials and early approvals, that's really helped. And then this issue of switching vaccines. Can you switch vaccines? Can you move from AstraZeneca to Pfizer or Moderna? Short answer is you can. And you're better off for it, frankly. And the other thing, to give credit where credit is due to the UK has been sequencing the genomes of 5 to 10% of people infected. That is tremendous. That's why we knew about the South Africa variant. That's how we figured out what was happening in Brazil. That's how we figured out what's happened in India. The UK hasn't done all of it, but it did the heavy lifting early, and it continues to do it. And the United States, even now, has been probably doing 5% of what the UK is, which means that they're running blind. Actually, while I don't have to say they've all been very, very effective, I'm not going to comment on the relative effectiveness of them, but except to say we've never in the Western world, we haven't seen any of the evidence from Russia, and we've seen some of the evidence from China. It's been published in good journals. On the whole, it's been really very successful. Now, just an illustration of the relative effectiveness. 2 doses of a Pfizer vaccine produced antibody levels 10 times bigger than 2 doses of the AstraZeneca vaccine. Now, that doesn't mean that your chances of getting the infection is 10 times more. The risk is that much higher with AstraZeneca, but it's an interesting difference. Those who received the Pfizer first and then the AstraZeneca second, well, that was okay, maybe 5 times the antibody level. Those who received the AstraZeneca first, and I think this speaks to a lot of people in Ontario who got AstraZeneca first, then followed, and then as Pfizer became available, and people were worried about the vascular complications with AstraZeneca, they wanted another choice. Well, it's interesting, it works, because Pfizer added on to AstraZeneca, and the antibody levels were almost equivalent. So the next big question, how long is the immunity going to last? The truth of the matter is we do not know. And is it going to last as long for older people? Probably not, as younger people. We know that mixing vaccine works. So the big issue now are these variants of concern. Here are the biggies. They've all been relabeled by the World Health Organization. So alpha, beta, gamma, delta. Interestingly enough, they all sprouted a year ago, 2020. Had their origins in 2020, and most of them in the fall of 2020. I think the earlier one was the beta one in South Africa, May of 2020. So that's when they first kind of we became first aware of them. Now I put this one up just to show that well, just take the bottom line here. The Pfizer vaccine, the gamma, that's the Brazilian variant here. We don't know what its effectiveness is with the South African variant. 92% with the UK variant, but less. for the Delta variant. I mean, this is the concern, because we have a virus out there that's multiplying like crazy, with billions of hosts, and the virus is showing a capacity to mutate, and to mutate to its own advantage, to make it more transmissible, and probably riskier, meaning patients are more likely to develop symptomatic disease, and if symptomatic disease, that disease will be worse. That's the worrisome thing, and especially if they find some way around the vaccine. Now, it's not as if all these vaccine companies have been sitting on the sidelines. They're well aware of these variants. I think there are now 20 variants of concern out there. They're well aware of them, and especially with the RNA vaccines, it's actually fairly easy to rejig the RNA to counter kind of new variants. So that's clearly possible. We may see that in the coming months, and certainly the next year. I mean, I think it's we're not out of this. This is going to go on. Now, there are some other tools. Some of them weren't used as much as they could have been. Convalescent serum and the bioengineered antibody infusion. Remember, Donald Trump got this, and they are actually effective taken early enough, after, in that first week, before moderate to severe illness develops. They're actually helpful. And an antibody nasal spray is being developed now, which is kind of an interesting thing. So when you get the first symptom, you just spray several times, and that seems to be in early days effective. Now, here's another issue that I wrote about. I think the last article in the Lake report, long COVID. These are long-lasting symptoms that follow COVID-19 infection. Now, there are two groups here. In the early days, in the early and middle days of this pandemic, when we were completely preoccupied with what was going on in intensive care units and overwhelmed with very sick patients, all of the focus was on people who were really ill. And some of them got out of ICU, but have been plagued by disabling fatigue, weakness, and what some people use the term brain fog, but really comes down to impaired memory or difficulties concentrating or focusing, and some trouble kind of controlling moods and sleeping. And so those symptoms, I have to say, those symptoms are actually fairly common in people who come out of ICUs for a whole bunch of other reasons. So it doesn't necessarily mean it was COVID. But then a whole new world opened up, because we became aware that some patients who had no symptoms ever early, but tested positive, or tested positive and had a few symptoms and skated through that first 2 or 3 weeks after, and nothing bad happened, then developed a constellation of symptoms. This brain fog, and fatigue, and muscle aching, and soreness, and change in bowel habit, etc. Long list of symptoms. And we're very much in the learning stage, but it seems to affect somewhere between 10 and 30%. One estimate had it up to 80%. That seems an outrageously high number, but 10 or 20% seems reasonable, of people were infected by the virus, but didn't develop those characteristic moderate to severe symptoms of a small minority, but developed these disabling things. They couldn't work, couldn't concentrate. Some of them just couldn't get around at home. So what was going on? Now, I can tell you that the United States and Canada and the UK, they're the ones that I know about, have taken this seriously enough that they're investing in research. I think the US has put over $1 billion into this, and the UK roughly half that. And I don't know what the sum is in Canada, but Canada is investing in this. So clearly, this is something that we need to understand. Now, so what's causes what causes these symptoms? I'll just go down to the historical antecedents here, but there is a history of this kind of thing. You've probably heard about the chronic fatigue syndrome, which has a fancy name, myalgic encephalomyelitis, which kind of implies that the brain and spinal cord are involved with muscle. That's essentially what the long word means. But that's been a mystery. That's been around for maybe the last 30 years of my practice. Something I saw in Boston a fair bit, because Lyme disease was fairly common in New England, was this phenomenon of post-treatment Lyme disease. That people they had a tick, they got infected, they were treated appropriately with the appropriate antibiotics, high dose, for a prolonged period of time, and they continued to have symptoms. And to a point where we couldn't identify any residual evidence that any part of the bacterium was still around. And so what was going on with these people? I mean, a lot of these people couldn't work, being quite disabled. Some of them ended up on recurring courses of high antibiotic doses, once a year, something like that. So this phenomenon of, the list could go on here, but this phenomenon of infection and a post-infectious prolonged period of a variety of symptoms that are very disabling is not new. It's been around a long time. So is it evidence that some part, in this case, of the virus is hanging around, or maybe even the virus itself is hiding out inside cells? Is it an autoimmune phenomenon or an inflammatory disease? What's going on? So far, we simply don't know. I have to say that just a week ago, the leading American general medical journal is the New England Journal of Medicine, and there was a letter to the editor and talking about long COVID, and with a historical perspective, but also pointing out that the medical profession, healthcare professions in general, have had an ambivalent response to this, because there are some in the profession who say, well, gee, I don't see it. As far as I can see, all the tests are normal. And I don't see any evidence of going on, anything that I could treat. And if unstated, there's the implication that the thought, well, it's all in their head. They're crazy, or something like that. Or a much more sympathetic and supportive take on it. And well, it's something we don't understand. And it seems to be serious enough. It involved people, a lot of people, and they're not nutcases. But I'm well aware of this ambivalence. I mean, I certainly lived in that climate in Boston, and in the later years in London, and I'm aware of this rearing its head again with this long COVID phenomenon. What is going on here? So, well, I don't have to list out all the symptoms related to long COVID. Just pulling things together, the cost of COVID-19, well, a hell of a lot of people have died around the world. And if 10 or 20%, even 5% of them develop long COVID, wow, that's a huge healthcare problem going forward, and with no clue about how we're going to manage. I don't have to say anything about the economic dislocation. Isolation, I do have this pandemic has had a cost, a social cost and a personal cost for many people. I think it's been very hard for people often who are living alone and for long periods of time couldn't contact their family, I mean, in the flesh. And that was certainly the case with my wife in the long-term care facility here. But I'm not just picking out Jan. Jan was one of 89 people or more kind of tucked away in a room for a long period of time, many weeks, being the meals being delivered to the door, unable to walk out of the room, and with a dementia where you can't figure out where the hell you are, or even the time of day, like sensitive situations and other people. It was terrible, and it's just now that she's Jan's beginning to recover, to make some recovery, and I would multiply that out over probably thousands across Canada and many more in the UK and the United States, around the world. So it's been a huge problem, and it's not something that the healthcare system thought about or even showed any acknowledgement of it while it was all happening. So that's, well, the gains, we said no colds or flu. Working at home, I don't know. That's a dicey thing. Some people liked it or have some pluses, but we all like to be close to people, and I find it hard doing programs like this because it's very hard to read people, to kind of know what you're thinking or how you're responding to stuff. That's really difficult. In the open kind of InfoHealth sessions and other programs that we have here, being live is a huge plus. So, what did not work? Well, I don't have to go on again about long-term care facilities. One of the issues has been mixing politics with vaccines and this vaccine reluctance. That's been a bit of a stunner for me because the number who are refusing or don't want it almost equals the number of, I don't know, it's the same population, but the same number that voted for Trump. And in kind of red states. And interestingly enough, that's where the pandemic is still going on. So and then this whole issue early in this thing, one of the items I wrote for the Lake report, it was pretty obvious to a lot of people that corralling the virus worldwide was the only way that this was ever going to be resolved. So it is not enough to sit in Canada or the United States, or the UK or Europe, or wherever it is, and solve it for us. It's going to come back and bite us unless we deal with it elsewhere. And that means supporting vaccines for other countries and getting the vaccines to them. So that's really important. Now, the journal Nature had several questions, but I think we've answered. How effective are the vaccines against variants? Quite good, quite effective right now, as of now. How long will they work? I don't know. Will we need regular boosters? Yes, for sure. When? I don't know, because it depends on question 2. How long will the vaccines work? How much do the vaccines block the spread of the virus? That's been a real discovery here, that people could have infections, test positive, and have no symptoms. Now, I guess intuitively, if you think about it, this isn't unique to the coronavirus, this particular coronavirus. There must be people who develop colds, acquire the virus, develop few if any symptoms, but can pass it on. The same is probably the same for flu. The same is probably true with other viral infections. So nothing new with that. But it does mean it's hard to identify them, right? When you get on an airplane or on a cruise ship. And what have we learned about adverse side effects? Well, I haven't spent any time on that. Maybe that'll come up with the questions. And long COVID we talked about. So the future is variants and continued surveillance, absolutely for sure. And continued vaccine development, and all of the primary manufacturers of the vaccines that we've had are on that one, are all over it. So here's another item. I'll close on this for the New York Times, but it closes it out. I thought it captures the way I feel about it. It's too soon to declare victory. The world is still locked in a race between the coronavirus's ability to evolve and vaccination. And our lead in that race is precarious. The virus is evolving quickly and efficiently. Give it enough time and enough susceptible hosts, it could still mutate its way around the human immune system and beyond the ability of existing vaccines to help. If that happens, United States, American newspaper, could be anywhere, and any other nations that have made such progress will be forced back. That's an almost intolerable thought after almost 2 years. The only way to prevent such a grim outcome is to vaccinate as many people as possible, as quickly as possible, not just in the United States or the Western world, but everywhere. Absolutely right on. I agree with that. Now, is that nice? That's a Van Gogh painting. Wouldn't you love to be working on a Van Gogh painting for days on end and at close range like that? Isn't that lovely? So, any thoughts or questions? I mean, we've all had our experience, haven't we? We've all had an experience of this. We've been all secluded, wearing masks, distancing, getting vaccinated, that kind of thing. But and we've had worries about it. We've been frustrated by inability to meet with family members, and so a lot's been going on in our own lives. Probably every one of us has their own story of this pandemic. But do you have any questions or no? I can't have said it all. I'm sorry, but yes. Norbert, yes. Now your fingers.
Okay, the question is this: how do mRNA vaccines work, and could they have a long-term adverse effects on the DNA of the recipients, like gene editing?
Yeah, that's a really interesting question that people have brought up as reason for not getting vaccinated. That somehow the RNA, or more especially the DNA, might be incorporated in the human genome Well, we know that's possible. At some point in this, I said that about 30% of the human genome has been donated from various viruses over millions and millions of years. So yes, can it be incorporated? Sure it can. What's been in the messenger RNA Moderna and the Pfizer one, and the AstraZeneca one, the messenger RNA has been made in the lab to only provide instructions for the to build the spike protein, not the virus, not duplicate the viral genome. Only that part that dictates the structure and function of the spike protein. That's very important. Even with the AstraZeneca, only the part of the DNA that contains the genes for the spike protein that were incorporated in the viral vector. But I will say that I've learned a lot about genetics in the last few years. Genes do once they're incorporated, they don't necessarily stay where they started. They can jump around in the genome. Every time a cell, a virus, a bacterium, or any cell in our body divides, there's a reorganization that takes place, duplication of genes, and exchange of genes takes place. And it's all very complicated, but the fact of the matter is that locations of genes can change, and genes definitely mutate for sure. If they hadn't mutated, we wouldn't be here because we wouldn't have evolved, be who we are. So it's part of basic biology that the DNA code, and if you think of messenger RNA is the middleman between the nuclear DNA in a cell and the protein making machinery, the ribosomes in the cytoplasm. So it's kind of the postman, carrying the mail from one to the other. But it's still, for example, I'm really excited about it. In the first InfoHealth program in January, we're starting out with a bang, because some of you who may have been there at the Nobel series may remember last year Jennifer Doudna got it for gene editing, and a lot of her stuff, all of her stuff really was at a very basic, fundamental level, but it's now it's right in there with treating human diseases now. There are now several diseases, and the number is growing, where gene editing, it confers an enormous advantage in treating some diseases that we've been completely unable to treat, and some of them are horrible diseases. So manipulating the gene in a lab, or it happening spontaneously the way it happens in nature, it happens. RNA is a more unstable, it's more unstable than DNA. DNA is stable because of the rungs that kind of connect the two strands. So it's harder to kind of change it. It still changes, but it's harder. But RNA was probably the first molecule of life to develop in maybe deep oceans, or maybe elsewhere in the solar system or beyond. But and it's quite capable of sustaining life and developing an array of other molecules, proteins, glycoproteins, sugars, that kind of thing. So, to your question, is there any risk at all of inoculating the human genome with messenger RNA and DNA? Yes. Is the chance of that? I think the chance of it is infinitesimally small. I might say one more thing here. Messenger RNA, the Pfizer one and the Moderna one, it really it doesn't last in the cell. It doesn't hang around in the cell. It's gone after it's done its job of kind of driving the manufacture of spike protein. That's it. It disappears. The DNA one, that's another matter. I don't know about that. We'll wait and see. But keep that program in mind in September, because that's a huge change in healthcare coming our way for some of the most intractable diseases in humanity. So now, I don't know whether I answered that question. That's a long way around. Did I? Okay.
Yes, you did. Thank you very much.
Okay. Any other thoughts? No? Everyone's happy. So
Can I ask?
So where the hell's the coffee? Yeah.
This is a question purely of interest. What caused this virus which affected the entire world one way or another? And there is nothing like this happened in the history of humanity before.
Well, it has. And as I told you, it happened 20 to 25,000 years ago because they traced it in people living today in China. Evidence in their genome of previous encounters with this coronavirus 20 to 25,000 years ago. So, and they were just looking for that. If you went fishing for other viruses, you'd probably find their fingerprints all over the human genome. And I would think anyone who's had a virus infection in their lifetime, some of that is kept in memory. After all, that's how our immune system recognizes a second infection. And to be more basic, gene editing really began with the question of how do bacteria remember previous viral infections. So when the next viral infection comes along, it can kind of destroy it. It does it by storing some part of the virus's RNA or DNA in its own genome, in the bacteria's genome. We have cells in our bone marrow, B cells, and various populations of lymphocytes that if we've been infected, if we've been infected with a common cold or flu or whatever it is, those cells retain some part of that RNA or DNA. And so when you're reinfected, if it's anything like the previous one, the immune system ramps up. So our immune system, we have, our memory isn't just of events in people's faces and that kind of thing, and the hippocampus in our brain. Our memory is actually in our bone marrow and every lymph node in the body, wherever there are lymphoid cells. There are memories of previous encounters with infection, and they can last a lifetime, right? That's what happens, for example, with chickenpox. If you have chickenpox, if I'm of the generation where I actually had chickenpox naturally, and the memory of some part of the genome of that varicella virus took up residence in nerve cells in my brain and spinal cord and dorsal ganglion cells, and is capable of mounting, if I was challenged again with the virus, a response to it. So thank goodness our body has this memory. I mean, isn't that what happens with cancer? Think about it. Cancer destroys our immune response to infection. What's it actually doing? It's destroying cells that have a memory for previous encounters with various infections. That's what's happening. So we don't want to do away with the memory system. I think this is really it's really quite important, and so a lot of the bacteria and organisms that populate our gut are part of our immune system, and they have memories. They have memories of various organisms that we've encountered. So so developing dysentery is not a good thing for the immune system, right? So we're losing memory cells that can help us out. In fact, I don't know whether I'm making it too complicated or too simple, but anyway, we do have this alternate and very important immune system that we don't ordinarily think about as memory. Okay. Anything else? No. Okay. Well,
if there are,
sorry.
I was just going to say, if there aren't any more questions, yeah, I would just like to thank all of you for coming. As Dr. Brown said, we are going to take a bit of a break over August and then restart again in September. And I'm not going to make any promises I can't keep about how that will happen, whether it will be via Zoom exclusively, whether we'll be able to have smaller.
We can pray.
You can pray, you can put it out into the universe, fingers crossed, toes crossed. Let's hope we can do it in some capacity in person or some kind of hybrid. Keep an eye out to our website, and yeah, we'll see. We just have to wait and see. Any other comments before we check out for the afternoon?
Yeah.
No?
Okay.
Oh.
Well, it's been fun. It really doesn't matter whether they're 30, 40, or 5 or 4.
No, that's true.
Yeah, it doesn't.
No.
And actually, it's been kind of nice here because I could actually see.
Mm-hmm. Yeah.
Yeah.
Thank you for taking time out of your day, everybody. I hope you're enjoying the hot weather.
Yeah, enjoying the hot weather.
Come see us. Our doors are open, so you're welcome to come and see us in person in that way. Otherwise, have a great day, everybody.
Good day, and thank you very, very much.
Bye.
Bye-bye.
Bye-bye.